These two engines may appear distinct, but they share a common characteristic: their creators classify them as single-cycle engines. As a mechanical engineer, this concept intrigues and makes me skeptical. What does single-cycle mean? Is it an innovation akin to an unknown rotary engine or merely an exaggerated marketing strategy? Let's uncover the reality behind the functioning of a single-cycle engine, its unique capabilities that set it apart from conventional engines, and, crucially, why someone would invest millions of dollars in developing an internal combustion engine, given the imminent transition to electric vehicles. The revelation promises to be surprising. Let's explore these questions together. Single-cycle engines, an analysis. Why is the idea of a single-cycle engine seen as peculiar? A single-cycle engine is a form of internal combustion engine. It operates by burning fuel within a chamber and converting that energy into rotation. There are various ways to achieve this, but the essential aspect is that the engine functions in a continuous cycle. In other words, it needs to burn a portion of fuel, transform it into motion, and then prepare to burn more fuel again. For this process to be viable, first stages are crucial: intake of air and fuel, compression of the mixture, power generation through combustion, and finally, expulsion of exhaust gases. Thus, we have intake, compression, power, and exhaust. In common gasoline cars, these four phases occur in distinct piston movements, known as cycles. These are known as four-stroke engines, being the most widely used. In some types of motorcycles and smaller engines, such as lawnmowers or leaf blowers, the intake and compression phases occur in the same movement, and the power and exhaust phases in the subsequent one. This characterizes a two-stroke engine. So, a single-cycle engine would combine all these four stages, intake, compression, power, and exhaust, into a single piston cycle. Now, let's think about how a single-cycle engine would compare. Imagine a cycle where a swimmer can generate thrust and move forward while readjusting to advance again. This vision is somewhat complex, but using swimming as an analogy can clarify why such a cycle is intriguing. However, it is fair to give the inventors the benefit of the doubt and examine the engines they have developed, starting with the so-called an engine. Innovations in engines, an overview. An engine is a company based in Granada, Spain, dedicated to developing innovative engine technologies for various applications. This organization is relatively modest in size, with a team of only 9 people. It was established in 2011 by a group consisting of Fernando Castañas, Roberto Lero, Ana Martín Moreno, who serves as the administrative director, and Juan Guedo, the investor and CTO of the company. The available information about the team members is limited. For example, Juan Garrido does not have a detailed LinkedIn profile, leaving his qualifications as an engineer uncertain. Roberto Lindaro, the vice president, apparently does not have a background in mechanical engineering or experience in the automotive industry. His 23-year career is focused on managing custom seating projects, such as for large events, suggesting that he is probably more business-oriented. The standout member of the group is Angel Herrero, an engineer specializing in simulation analysis working at an engine. The company is relatively young but has been operating for 13 years, during which it has developed 2 main products, the AirX engine and the REX-B. These are described as revolutionary single-cycle engines, patented due to a notable feature. Their innovative design of opposed pistons allows the pistons to move in balance, canceling out the forces between them in 3 distinct planes. A technical peculiarity is that the piston's movement is controlled by the shape of the cam track, not by levers or a crankshaft. This eliminates secondary imbalance, common in many engines that tend to vibrate when operated at high revolutions per minute. The result is what could be the smoothest internal combustion engine ever seen. As a curiosity, the inventor took the REX engine for a test at the University of Valencia, one of the most sophisticated thermal engine test benches in Spain. He shared that the test recordings were so silent that investors doubted the engine was running, thinking the video was a montage. This highlights how impressive the engine's operation is. However, a question remains: is it really a single-cycle engine? To investigate, I analyzed slow-motion videos of the engine. Focusing on a cylinder with 2 pistons, I observed the power phase, where sparks are fired, and the gas is ignited. As the pistons move outward, reaching full expansion, they pass the exhaust port, and the gases are released. Simultaneously, the exhaust phase occurs, still during the power phase. According to an engineer, the exhaust gases exit so quickly that they create a vacuum inside the chamber, drawing in ambient pressure air when the piston reveals the intake port. This is intriguing. The idea that the fleeting exhaust air generates a vacuum so powerful as to completely absorb the air needed for the next compression cycle is, at first, questionable. However, after further analysis, it seems plausible. Following the intake of fresh air, fuel is directly injected into the chamber, mixing with the air as the pistons move back towards each other, compressing the mixture. Once compressed, the mixture is ignited again by the spark plug, restarting the cycle. This process, although simple, is considered quite innovative. But wait a minute, the intake and compression occur after the power stroke when the pistons are returning. This is the second stroke. If this sounds familiar, it is because it really is. It is a typical 2-stroke cycle, not just one. So, why does a company insist on calling this a single-stroke engine? Understanding 2-stroke engines. It deeply bothers me when companies make exaggerated claims like this without meeting expectations,